Okay, we'll look at some of the homework problems in section 12.2 where we were dealing with some of the properties of quadrilaterals. Also, we were looking at the side angle side. I'm sorry, the angle side angle property. And here, number one, you want to determine whether the conditions angle P is congruent to angle M, angle Q is congruent to angle N, and angle R is congruent to angle O are sufficient to prove that triangle PQR is congruent to triangle MNO. And you want to justify your answer. Okay, so in section 12.2, we were dealing with side angle, and also angle, angle, side as well. So now we want to draw two triangles. This one is triangle PQR. And this one, I'm going to label this as triangle MNO, like this. Okay, so in this case here, we want to mark off angle P is congruent to angle M. Angle Q is congruent to angle N. And angle R is congruent to angle O. Now, would this be sufficient to prove that those triangles are congruent? And the answer there would be no. Because all we know in this case here is that the angles of one triangle are congruent respectively to all the angles of the other triangle. But it's not enough for me to prove by using the angle side angle or the angle angle side theorems that those triangles are congruent. So the answer there will be no. And when we justify our answer with the congruence condition, the answer will have to be none. Okay, because all we know that all the angles of one triangle are congruent respectively to all the angles of a second triangle. We don't know anything about the lengths of their sides or the congruence of their sides, so it will be none of these two properties here. Okay, the next problem. In each of the following, you want to fill in the word needed to make the resulting sentence true. Okay, so here part A is this: a quadrilateral is one of these, and that's if and only if its diagonals are congruent. If and only if its diagonals are congruent, one of these is a quadrilateral. In this case here, it's going to be the rectangle. And the reason for that is, in a rectangle, the diagonals are congruent. Okay, because we know it's not going to be the square because the square is a rectangle. And then a rhombus would not work because one of the diagonals is longer than the other. The same with the isosceles trapezoid and also the kite and the parallelogram and the trapezoid. So only the rectangle, the quadrilateral is a rectangle if and only if its diagonals are congruent. Okay, part B of number 2 is this. A quadrilateral is going to be one of these if and only if its diagonals are congruent. And in this case, that answer there is none. Because a quadrilateral, well, it's saying if and only if the diagonals are congruent. That means if the diagonals are congruent, then such and so and so, one of those would be a quadrilateral. Okay? There's needs to be more information for that to say that the diagonals are congruent. So the answer there would be none. Okay. Now, problem number 3. Classify each of the following as true or false. Part A, no trapezoid is a square. No trapezoid is a square. That would be false, because a trapezoid can be a square, because a trapezoid is a quadrilateral where at least one pair of parallels, where you have at least one pair of parallel sides, and a square can be a trapezoid can end up being a square. Okay, and that should say not all squares are trapezoid. This one says no trapezoid, and that would make that a false statement. Part B, all squares are trapezoids. In this case, that's true, because all squares have all the properties of a trapezoid. Not only that, it does have the properties of a parallelogram and a rectangle and a rhombus. So all squares being trapezoids would be true. Okay, problem number 4. Classify the quadrilaterals ABCD and ACDF formed from the regular hexagon ABCDEF. Okay, in this case here, part A, quadrilateral ABCD forms which one of those 3? Now if I'm going to copy down the hexagon, and then in a different color I'm going to highlight ABCD. Okay, and D is going to go to where A is. Okay, and this is a regular hexagon, meaning all the sides are equal. That means that this side is equal to this side. So here, this quadrilateral ABCD is an isosceles trapezoid. So here we'll select the one that says isosceles trapezoid. Then part B, quadrilateral ACDF, forms one of those 3. Okay, so here we want to highlight ACDF. Here's A to C to D all the way to F. And we'll connect F to A. While looking at this figure represents a rectangle, okay? Because these sides are equal, these opposite sides are equal. And I'm sure the distance from A to C is also equivalent to the distance from F to D. So this would be a rectangle. Okay? So sometimes it does help to trace in those trace in whatever that particular quadrilateral represents from the regular hexagon. Okay. Problem number 5. Okay. Determine whether the conditions PR is congruent to MO, QR is congruent to NO, and those are line segments, by the way, and angle P is congruent to angle M, are sufficient to prove that triangle PQR is congruent to triangle MNO. And it's either going to be by the angle side, or AAS, or angle side angle, which is ASA, or none. And a good way of finding out that will be to draw two triangles. Here's P, Q, R, M, N, O. So in this case here, we need to mark off those angles and those sides. Line segment PR is congruent to line segment MO. Line segment QR is congruent to line segment NO. And angle P is congruent to angle M. Okay. Now, would this be sufficient to prove that angle PQR is congruent to angle MNO using angle side or angle side angle? In this case, it's no, because we got an angle and two sides. Angle and two sides. So the answer there will be no. Okay, so that means it would not be either the angle side or angle side angle. So we have to select none as our answer. Okay. Problem number 6. Classify each of the following as true or false. In part A, a square is a rhombus. Well, the square has all the properties of a rhombus, so that means that statement is true. And part B, all squares are trapezoids. Again, that's true because, again, squares do have all the properties of a trapezoid and a rhombus and a parallelogram and a rectangle. So that's true. Okay, and finally, number 7. Classify the quadrilaterals ABCF and ABDF formed from the regular hexagon ABCDEF. Okay, so here quadrilateral ABCF is going to form one of those three. I'm just copying the hexagon as is. Now let's trace in ABCF. Okay, here's A, going to B, to C, and then to F. Coming this way. And then F will go back to A. Okay, in this case here, AF and BC are equal because this is a regular hexagon. So here, this would represent, in this case, an isosceles trapezoid. An isosceles trapezoid is where the sides, the non-parallel sides, are congruent. And then quadrilateral ABDF forms one of those three. And again, I'm going to go ahead and draw that hexagon. And ABDF is going to look like this. Here's A to B, B over here to D, D is going to go to F. And then I'm going to connect F to A. Now, this is not the best drawing, but if you look at this, AF and AB are congruent to each other, so that means the distance from F to D must be equivalent to the distance from B to D. In this case, this would represent a kite. Okay. So this should assist you with some of the problems in section 12.2.